Welcome to my third lesson on analytical geometry, the equation of a tangent to a circle, given point on the circle. I am Maimela Maharani. At the end of this lesson, you should be able to find the equation of the tangent to a circle, get more practice on finding the equation of tangent to a circle, and apply knowledge of tangent to higher level questions. Before we start with the equation of a tangent to a circle, let's start by looking at lines on circles. Right, if you look at this line and the circle, your line AB, you can see that line AB does not intersect or touch the circle. So there's no relationship between this line and the circle. So if you are asked to solve for x and y, for equation AB and the circle, you will get no solution if you want to solve for x and y simultaneously. Right, let's look at this another line CD. So this line intersects the circle at exactly 2 points. So this line is called a secant. A secant is a line that intersects a circle in exactly 2 points. So we have line CD, which intersects the circle at this point and this point. So this line is called a secant. It intersects the circle at exactly 2 points. So we have another line EF. So if you look at line EF touches the circle at exactly 1 point. So this line is called a tangent. So it touches the circle at exactly 1 point. Also your line HG is also a tangent because it touches the circle at 1 point. So line EF touches the circle at 1 point. Line GH touches the circle at exactly 1 point. Very, very important. Now we have another line which is from the center of a circle to the circumference of the circle. This line is called a radius. It's from the center to the circumference. And we know that a tangent is perpendicular to the radius drawn at the point of contact with the circle. So this means that this angle is equals to 90 degrees because a tangent is perpendicular to the radius. So this angle is equals to 90 degrees. This is very, very important in analytical geometry and geometry. The radius is perpendicular to the tangent at the point of contact. Right, we have another line which is called the normal. The normal to a circle is a straight line drawn at 90 degrees to the tangent at the point where the tangent touches the circle. So, and also it's important that to note that the normal always passes through the center of the circle. So the normal is the line, a straight line drawn at 90 degrees to the tangent at the point where the tangent touches the circle. So this line is called the normal because the angle between the tangent and this line equals to 90 degrees. So this line is also important. Right. Now let's look at the relationship between tangent and circle. Now if you look at this bicycle, we can see that the spokes of this bicycle are from the center to the circumference of the circle. So the spokes of this bicycle represent the radii. They represent the radii of the circle. So we want to look at the relationship between this wheel and the road. Now, if we look at this wheel, we can see that at the point where the wheel touches the road, the wheel is tangent to the to the road. So if this is your R71 road and this is the wheel on the road, so we can see that at this point the wheel is tangent to the road. It touches the road at one point. Therefore, the wheel is tangent to the road. And this spoke is perpendicular to the road at this point of contact. So the angle here will be 90 degrees. So it's very, very important. So also it's important to know that if you are asked to solve for x and y with the equation of the tangent and the equation of the secant, you'll only get one x and y value because the tangent touches the secant at exactly 1 point. Very, very important. So the radius is perpendicular to the tangent at the point of contact, and also that the tangent touches the secant at exactly 1 point. Now let's look at the summary on lines on circles. So here we have a circle with center O and PQ. Straight line PQ does not touch the secant. There is no common point between the straight line and secant. The number of points of a line and circle is 0. So there's no point of intersection. So therefore, if you solve for x and y, you'll get no solution. So here we have a line that touches a circle at 1 point. Straight line PQ touches the circle at a common point A. PQ is called the tangent to the secant at A. So this is tangent to the secant at A. So A is the point of contact. Therefore, the number of points of intersection of a line and circle is 1. So we only have 1 point of intersection. So here if you solve for x and y simultaneously, you'll only get one x value and one y value. So the next one, we have a line that cuts or passes through the secant. Straight line PQ intersect the secant at 2 points A and B. The line PQ is called a secant of the secant. Therefore, the number of points of intersection of line and secant is 2. So here, if we solve for x and y, we should get 2x values and 2y values. Right. Now, we've showed that a tangent is a straight line that touches the secant at exactly 1 point. So now let's look at how to find the equation of a tangent to a secant. Since a tangent is a straight line, it is a linear function for which an equation can be found, meaning that we are going to use a linear equation. We are going to work with a linear equation. Forms of a straight line equation, we have y equals to mx plus c, which is our standard form. So where your c represent the y-intercept and your y, m represent the gradient. And we also have the general form of equation, which is ax plus by plus c equals to 0. We can use y equals to mx plus c or y minus y1 equals to m into x minus xy, where m equals to gradient. Finding the equation of a tangent to a circle given the point where the tangent touches the secant. So now let's look at the steps of finding, or the method of finding the equation of a tangent to a secant. So step number 1, draw a sketch with radius from the center to the point of contact with the tangent to the secant. So we want to find the equation of a tangent to a secant given the point where the tangent touches the secant. So it means we have the center and we have the point where the secant touches, the secant and the tangent touches. So we draw a circle with a radius and a tangent to a circle. Calculate the gradient of the radius. Firstly, we calculate the gradient of the radius. So how are we going to calculate the gradient of the radius? We use the point given, which is the center and the point of contact. Step number 2, to obtain the gradient of the tangent, change the sign of the gradient of the radius, invert it, you turn the number upside down. Tangent is perpendicular to the radius. Very, very important. So therefore, the gradient of the tangent, the gradient of the radius times the gradient of the tangent equals to -1. We now have the gradient of the tangent and the coordinates of the point through which the tangent passes. Substitute the gradient of the tangent and the coordinates of x1 and y1 of the point into the formula. Y minus y1 equals to m minus x1 to determine the equation of the tangent. Now let's look at an example and use the steps to solve the problem. Find the equation of the tangent APB, which touches a circle center C with the equation x minus 3 all squared plus y plus 1 all squared equals to 20 at P53. So if we look at this statement, we can see that we have a tangent to a circle at point P, and we are given the point 53, which is the point of contact. And we are also given the equation of the circle. Therefore, we can be able to find the center of the circle. So we know that the center of the circle is 3, -1. So don't forget to change the sign when you move from the equation to the center of a circle. So from the steps, our step number 1, which is optional. You don't have to draw the diagram if you know how to solve this thing. So the diagram is optional because there's no mark for drawing the diagram. So you can still get marks even if you don't draw the diagram. So if you understand this question without the diagram, you can still do it without the diagram. Draw a sketch to help you. So the sketch is only to help you. So here is the sketch. We have circle with center C and tangent APB with a point P53. Right. Step number 2, calculate the gradient of the radius. So we know that to find the equation of the tangent, we always use the gradient of the radius if we are given the center and the point of contact. Since the gradient of the radius times the gradient of the tangent equals to -1. So therefore, we can be able to find the gradient of the tangent. So to calculate the gradient of the tangent, first we can start by finding the center, C, which is 3 minus 1. Very, very important. Don't forget to change the sign. So the gradient of the radius, CP, MCP, equals to y at P minus y at C divided by x at P minus x at C. So always write the equation, the formula for the gradient. Very, very important. So I prefer to write it as M, small letter m, CP equals to y at P, which is the y value at P, minus y at C, which is the y value at C, x at P, which is the x value at C, minus x at C, which is the x value at C. So I'll know when I substitute, I won't have a problem. Right, so let's substitute. So our y at P, it's 3, and our y at C is -1. Therefore, we'll have 3 minus -1. Divide by x at P, which is 5, and x at C, which is 3. Therefore, we'll have 5 minus 3. Therefore, our gradient equals to 2. Step number 2, we know that you must invert change the sign of the gradient of the radius and invert it, turn the number upside down. Tangent is perpendicular to the radius. The gradient of the radius times the gradient of the tangent equals to -1. So we'll have radius is perpendicular to the tangent, so the gradient of the tangent times the gradient of the radius equals to -1. Therefore, the gradient of the tangent equals to -1/2. Now we go to step number 4. Substitute the gradient of the tangent and coordinates of x at 1 and x at 2 of the point into the formula y minus y1 equals to m times x minus x1 to determine the equation of the tangent. Right, very, very important when you substitute here. Which point are we going to substitute? Are we going to substitute the center, or are we going to substitute the point of contact? We don't substitute the center because the tangent does not pass through the center. It passes at the point of contact. So we'll substitute point P. So we'll substitute x at P and y at P. You can also use the equation y equals to mx plus c, where you c represent the y-intercept. So you substitute the gradient and then you solve for c. Right. So now let's substitute. So we have y minus 3. y1 is our y at P equals to -1/2, which is our m, which is gradient, into x minus 5. 5 is our x at P. P is a point on the tangent, so not C. The tangent does not pass at C. Therefore, we'll have y minus 3 equals to -1/2x plus 5/2. Y plus because we've multiplied by negative, so which is 2 whole number 1/2. Then our gradient, our equation is y equals to -1/2x plus 11/2. So we take 3 to that side, then we'll have 11/2. So it's very, very important to do step by step to solve this equation. So if you are given the center and the point of contact, you use the 2 points to find the gradient of the radius. After finding the gradient of the radius, you use the fact that the gradient of the radius times the gradient of the tangent equals to -1 to find the gradient of the tangent. Then from there, you find the equation of the tangent. Now let's look at another question. The equation of the tangent to a circle. The line defined by y plus 2x equals to 11 is a tangent to a circle with center P 1, -1 at the point Q, xy. The first question, determine the equation of the radius PQ and hence the coordinates of Q. Second question, determine the equation of the circle through Q with P, with center P. So before we even go to the question, let's start by looking at the given statement and the diagram. So it's important, very, very important in geometry, before you answer the question, understand the given statement and also understand the diagram. Analyze the diagram and the given statement. So we are told that the line defined by y plus 2x equals to 11 is a tangent. So meaning that we are given the equation of a tangent, and which is not in a standard form. Right, and we are also told that P is the center of the circle. If you look at the diagram, we have P as the center of the circle, 1, -1. And we are also given point Q, which is the point of contact between the tangent and the circle, and also the radius. So Q represents the point on the circle where the line is tangent to the circle, and also the point on the radius. So it's very, very important so to understand point Q. So point Q is the point on the circle, is a point on the tangent, and it's also the point on the radius. So we have radius PQ. So now, if you look at what is given, we are given the equation of the tangent, and we are not given this time we are not given the equation of the second. We are only given the center, and we are also given a point Q without the coordinates. We are just told that Q is XY. So the first question says we must determine the equation of the radius PQ and hence the coordinates of Q. So it's very, very important. Here we are not asked to calculate the radius. So we are not looking for PQ. We are looking for the equation of PQ. So we are looking at PQ as a line. We are not looking for the distance. Therefore, we are not going to use the distance formula in this question. We are looking for PQ, the equation of PQ. So now, if you look at this question, in the previous questions, we were given the equation of the second, and then we were asked to find the equation of the tangent. So this time we are given the tangent, the equation of the tangent, so we should calculate the equation of the radius. So previously, in the previous question, we were using the equation of the radius or the gradient of the radius to find the gradient of the tangent. So we'll do the same thing, we reverse. We are going to use the gradient of the tangent to find the gradient of the radius, so that we can be able to find the equation of the radius. So after finding the equation of the radius, we can be able to find the coordinates of Q. Since Q is the point of contact for the tangent and PQ. So we'll solve for x and y simultaneously using the equation of PQ and the equation of the tangent. And if you look at the next question, determine the equation of the second through Q with P center. So if we know the radius PQ and we also have P as our center, we'll be able to find the equation of the second. Since to find the equation of the second, we need the center and the radius. Now let's look at this question step by step. Now we want to find the equation of the radius, which is PQ. To find the equation of the radius PQ, we are given point P. We don't have the gradient. Since PQ is a straight line, we're going to use the equation of a straight line. So to find the equation of a straight line, we need a point and the gradient. To determine the equation of any straight line, you need to find the gradient of that line and a point on that line to substitute to the equation y minus y1 equals to m into x minus x1, where m represents your gradient and y1 and x1 represent the coordinates of the point. So let us write the equation of the tangent in the form y equals to mx plus c, so in the standard form. So if you look at this equation, it's not given in the standard form. It's y plus 2x equals to 11. So firstly, we must write it in the standard form. So we must make our y subject of the formula so that we can be able to find the gradient. So we'll have y equals to minus 2x plus 11. So therefore, the gradient of the tangent is negative 2. Very, very important. So firstly, you must write your equation in the standard form. And we know that the gradient of the tangent times the gradient of the radius equals to negative 1, because the radius is perpendicular to the tangent. Therefore, the gradient of the radius is equals to 1 over 2. Therefore, the equation of the radius PQ is y minus y1 equals to the gradient of the radius times x minus x1. Then we can substitute our gradient, which is 1 over 2. Therefore, we have y minus y1 equals to 1 over 2 into x minus x1. So from there, we substitute the point. So very, very important. Which point are we substituting? You must substitute the point which is on the radius. So the point which is on the radius this time is our P. So we don't have Q. So therefore, we'll use P. So you don't use any point. You must use the point which is on the radius. So this time we are given P, therefore we'll substitute P as our point. Therefore we'll have y minus negative 1 equals to 1 over 2 into x minus 1. So our y at 1 is 1 and our x is 1. So don't forget that when you substitute, be careful when you substitute. So we have our negative 1. So you have y minus 1. Very, very important. Therefore, we have y plus 1 equals to 1 over 2 x minus 1 over 2. Therefore, our equation of the radius PQ equals to y equals to 1 over 2x minus 3 over 2. So always very, very important. Verify your gradient. So the gradient of the tangent times the gradient of the radius must give you negative 1. The question continues, hence the coordinates of Q. So we want to find the coordinates of Q. We know that Q is where our tangent and radius intersect. Therefore, we'll have to solve for x and y simultaneously using the equation of the radius and the equation of the tangent, since Q is the point where the tangent and the radius intersect. The equation of the tangent is y plus 2x equals to 11, so you can call it our equation A, and the equation of the radius is y equals to 1 over 2x minus 3 over 2, you call it equation B. So we'll substitute our equation B into equation A. So y plus 2x equals to 11, our y will be 1 over 2x minus 3 over 2 plus 2x equals to 11. Then we find our lowest common denominator. Since we have fraction, our lowest common denominator is 2. We multiply out by 2. When we multiply out by 2, 1 over 2 times 2 is x. 3 over 2 times 2 is 3. And then 2x times 2 is 4x. 11 times 2 is 22. Then from there we add our like terms. We have 5x, we have x plus 4x, which is 5x. Then we take 3 to the other side. We have 22 plus 3 equals to 25. Therefore, we have 5x equals to 25. Therefore, x equals to 3. So we found our x value. Therefore, we can substitute our x value to find our y value. So we substitute into B, x equals to 5. You can also substitute into A. You still get the same y value. Therefore, y equals to 1 over 2 times 5 minus 3 over 2. Therefore, our y is equals to 1. Don't forget to write your Q, the coordinates of Q, which is the coordinates of Q are 5, 1. So we found the coordinates of Q. Then we go to the next question, which is B. Determine the equation of the second through Q with center P. Now we want to find the equation of the second. We know that to find the equation of the second, we use our equation x minus a squared plus y minus b squared equals to r squared. And we know that the coordinates of the center is a and b, AB, and r represent the radius. So to find the coordinates of the equation of the second, so we need to find the center and the radius. So here we are given the center, which is P, 1 minus 1. So therefore we must find the radius, the length of the radius. So we'll use distance formula to find the radius. PQ squared equals to 1 minus 5 plus minus 1 minus 1. So our 1, so we know the distance formula is x at 1 minus x at 2 squared plus y at 1 minus y at 2. So 1 here represents the x value, and minus 5 is also our x value. So minus 1, this is our y values for P and Q. Therefore, r squared equals to 1 minus 5 all squared plus minus 1 all squared. Therefore, r squared equals to 20. To find the equation of the second, we go back and substitute to the equation x minus a squared plus y minus b squared equals to r squared. So we must be very, very careful when we substitute from the point, from the center to the equation. We know that our a represents the x value and b is our y value. So when you substitute, it's very, very important. So we substitute our a here will be negative, will be 1, since our equation is x minus a. So we'll have x minus 1 squared plus y plus 1 squared. So since our b is negative, we'll have negative times negative, then we have positive y all squared equals to 20. So this is the equation of the second. So we've used the center, which is p, and we've used the distance formula to calculate the length of the radius. Right. The table below provides reference to this topic in grade 12 textbooks. So you can practice this from different textbooks. Mind Action Series, page 228, exercise 3. Platinum, page 188, exercise 2. Via Africa, page 215, exercise 6. Clever, page 250, exercise 10.3. Classroom Mathematics, page 252, exercise 10.4. Everything Maths, Seavula, page 304, exercise 7.3. Thank you very much. Enjoy.